Game on. Blah 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 blah. So, I get that earbud out. Teaching in America. Look at 4 people. All right. So, did you hear that? All right. I gotta hurry up because fifth hour I'm missing and through seventh. Like after a 4-day weekend, I'm in a little thing about learning about a new program second half of the afternoon. So I have to get a movie for fifth hour if they want to see this. So fifth hour. This is actually on an old homework question. It's in the homework, but I didn't feel like printing a second page. So look at your note sheet. The notes are in the front, and then what's the homework? 1 through anyone? No, it doesn't say 1 through 12, does it? No, it says 1 through 10 on the homework. Yeah. So the homework's on the other side. Yeah. So what I wanted to do is I didn't want to print a second page of homework. So just look at the key fourth hour. You're gonna actually do this in class when I'm done with making this video. So I'm gonna pick 1, 2, 3, 4 groups today at the end of the notes. So you're on. You know what I've been doing. I want to see people doing stuff. And then these notes, I really condensed them. What are the rules for adding, subtracting rational expressions? What are the rules for adding? What's the number one thing we got to do? We got to get a common denominator. I'm not stepping this out. I'll step it out down here. So I wanted to condense the notes so it was 1 page of notes, flip it over, 1 page of homework, saved 39 pieces of paper. Okay? Does that sound okay? All right, so you're going to do these two. I'll get you, and then I'm going to show you like how you do these. I'm going to skip a couple of these note examples. You fifth hour people look at the key to the notes for the ones that I don't do. Fourth hour, you're going to do them all just because I'm here. What do I get when I want to add or subtract fractions? A what? You didn't say it. Go ahead. A what? Common denominator. What is that common denominator? So this is easy. This is easy. The common denominator is 12. Okay. So what do I have to multiply the top and bottom by? What do I have to multiply this first fraction by? 4. So insert that in there. Whenever you're on a test, and that's the written portion, really try to insert those in there so you don't have to write any extra steps. Does the second one need anything? Nope. What's the third one need? What's the third one need? 3, but you multiply top and bottom. So up in the directions that I think the other teachers are writing out as long stepped out sentences. Yes, you need a common denominator. The next thing from grade school you need to remember is you multiply everything by that common denominator. Now in the numerator, you do want to distribute. I know there was like when complex fractions happened, you wanted to leave maybe some stuff in factored form to see if there's a canceling later. When you're adding fractions, you want to you want to get the numerators multiplied through, crinkle, crinkle, time for water. And then the whole point, shaking that head too, hurt his neck too. All right. But what's the whole point of getting a common denominator? I love it. He's still doing it. I think he's got a. All right. What do? You put them over that common denominator, right? There's another crinkle. I love it. I love it. I love it. I love it. All right. And then minus 3z. So the whole point of getting a common denominator is to put everything underneath that common denominator. Am I going too fast? It really should not be because it is grade schoolish, the rules. But a grade schooler can't do this because they freak out over the variables. All right, and then this is why I said this 4x plus x is 3x. This is why you must. 5x, good. I've seen if they were paying attention. Woo, long weekend. All right, and then minus 3z all over 12. What you should look at in the numerator is there a greatest common factor or does it factor? And it doesn't, right? There's nothing that can be taken out between 5, 8, and 3, x, y, and z. That's good. Oh, wait. Remember Friday? Should I cancel that 8 and that 12? What kind of error is that? A 6 over 5 equals 2 error. You can never take part of a sum and cancel it. That's illegal math right here. Not equal, not equal. That means that's bad, and you should be arrested if you do math like that. thrown in math jail. Okay, all right, let's move on. All right, I just want to get this video done so they have something to look at. Okay, and I don't know what to tell you other than just figure it out. What's the LCD? 2x squared. So what's this missing? This is just missing a what? 2x. The other one is not. I don't know why I'm putting things in parentheses. But that's how you want to do a test that's written. You want to squeeze. You want to do this in your homework. You don't want to retype everything or rewrite it all. 2x plus 1 over 2x squared. I mean, that's all that happens. You add the numerators and you carry the common denominator. Fine. I don't like that. Okay, fine. This is 2x over 2x squared plus 1 over 2x squared. Oh, then these cancel. When people do that, then how long are they on this question? Starts with an I, I-N, INF. Infinite amount of time, because you just created that common denominator. Oh, then let's cancel it. Well, then let's get a common denominator. Let's cancel it. Create, cancel, create, cancel, create, cancel. I get goofballs doing that all the time. Crazies. All right. So, and then you add the common, wrong. Add the numerator, put them over a common denominator. Oh, then of course this 2 cancels and this x cancels. And again, 6 over 5 equals what? 0. No, that's not true either. That's a 6 over 5 equals 2 error, right? You don't cancel those. Whoops, backed up too far. Beep, beep, beep. Okay. So is this the final answer? Yes. So no, you can't cancel the 2 and the x. All right. Drink time. Always love it. One example, one drink. Whew. It's just a very thirsty job in math. Crinkle, crinkle. There's another one. Oh, it's tough. You know what? That's it. Someone's doing this one. Next. Okay, so that's what we're going to do on the board. So those in 5th hour, you just go ahead and read that example on that one. I want to see if they're paying attention. Then we're going to have a real doozy for the last one. Anyone know what doozy stands for, by the way? You can't answer. Of course, he doesn't listen. You can't. Do you listen? I told you this last year. Who else is another one? Over there. Doozy is actually, did anyone ever hear that? What a doozy. What does that mean? Like tough one, like fancy, whatever. It's from a 1930s car called a Duesenberger. It was actually a really fancy car. So when it drove by, you go, what a doozy. Get it? So you can put that in your notes for non-math material. George is putting it down. That's a good one. All right, this one I'm going to go ahead and factor. You remember that from last year, George? No. All right. George, you're in the movie. All right, and then here's what you want to do. Minus 2 over, what is the denominator? 1. Okay. Is she not following along with ours or what? What are you looking over there for? The old one? Okay. Oh, don't be doing 3. They're doing 3 while I'm doing 4. Oh, goofballs. Okay, so what is the least common denominator? What is it? What is the common denominator? X plus 3 times 3. That's different than x plus 3. That 3 is not the same as the plus 3 in the middle. So here's the LCD. It's this one. So what's this missing? What's the first one missing? A 3. So you insert it. So this one I had to factor. That's why I had to write it, out a little bit. And then this one's, what's this one missing? All of it. 3 times x plus 3. But why is it top and bottom? Because that green equals what number? What does this equal? 1. You're multiplying each fraction by forms of 1. That doesn't change the value of the fractions. Change the way they look, but they're still numerically, even with the variables, numerically, they are still the same. And then you know what you do? Maybe this one I'll slow down a little bit. 3x first numerator, x second numerator, minus, what's 2 times 3? 6 times x plus 3. See, this is what I mean about this. You have to clean up the numerator because the whole point of getting a common denominator is to put it under or over one common denominator. Okay, that's the whole point of getting a common denominator. 1/2 plus 1/2 is 2 halves. 1 plus 1 over 2. 1, 2. We shouldn't have to, as an honors student, have to show that. Maybe the others, maybe when they said, hey, what's 1/2 plus 1/2? Now that they have a common denominator, it's 1 plus 1 over a common 2. That's how I get 2 halves. If I ate half a pizza and someone else ate the other half, which at home I just eat the whole because I'm a slob. All right, I did that last weekend with a Jack's pizza, but nobody cares. That's a full pizza. Anyone have a Rosati's in the area? You know what Rosati's pizza is? They're selling pizzas right now for I think $3.50 for a 2-topping large or medium. Did you know that? Did you hear this story? It's their blank year anniversary, so they're selling their pizzas what their original price was. So go out and check that out. Fifth Hour. See, telling you more than just so we can talk about doozy and then pizza on sale. Now it's participating ones, so I don't know if it would be ones in your area. Call ahead. Okay, then you have to distribute. All right, then I better slow this down. 3x plus x, I go a lot faster, minus 6x minus 18. I got to clean that up further. Leave the denominator factored because we might have to factor the numerator and cancel. 3x, 4x, that's negative 2x minus 18 over blah, 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 because then I'm going to take out a negative 2, and then I get x plus 9. I should check that. Then I'll put this over 3 times x plus 3. You can leave it in factored. You should leave it in factor, or you should get it in factored form in case something cancels. But if it doesn't, you're not required to redistribute and write it in, multiplied out form. Ruh-roh. I don't know. Decide it yourself. Reader. Seems like that's. You're not one of those bums that try to get away with the system with all. For 3 years at Compass, right? You know what I'm talking about. He was a BCer. No, he's still a BCer. He's a senior. So yeah, he was a Math 2 honors. All right, and then dun dun dun. Ooh, we're gonna see on that one. That's gonna be fun. Okay, then the last one. Hey, 4 minus x. What do you think you're gonna do about that? What's 4 minus x become? Okay, negative 1. Now, in the purpose of doing the subtraction, what I think you should do with this negative, and again, negative 1 over 2 equals 1 over negative 2, which equals negative 1/2 as a big fat negative out in front. The only thing I'm trying to get you to understand is I can take this negative and I can float it up to the top, and that might be helpful so that I have a little bit easier common denominator thing. So let's rewrite that. I took out a negative out of the bottom and I threw it up to the top so that I just spit on the screen. Good thing that was in an old. Anyone have anyone ever teach on the overhead? You ever see an overhead? The thing in the middle of the room that shoots an air light. Anyone ever see that? But I just wanted to bring up when you spit on that, then the kids would see it and they go, ew. Anyway, so I got you that image for you. And then it happens. I'm just human. I wish I wasn't. Just as an alien traveling the universe, finding out secrets. What's the LCD now? You see why I did that 4 minus x into an x minus 4? The LCD is, class? Time for a drink. Hold on. Okay, we did 1.5 examples. Okay, now what? See, 4 years ago, it used to be illegal to have drinks in class. Now these go, okay, I'm dying. All right, the kids of today. But anyway, what's the LCD? X minus 4, x plus. I love some of the looks I get too. I love it. I love the looks. Better watch it. Your face may freeze that way. All right. Multiply top and bottom by x plus 4, or the eye rolling. No, oh, my eyes are stuck. The eye rolling is my favorite too. Teaching in America. Okay, so only the first fraction is missing a denominator piece. One more thing you should do. You should make this plus a negative in case there were some things to distribute in the right, you distribute that minus sign. Non-distributing a minus sign really drives me nuts. All right, in the numerator, you do want to clean this up. Clean up, clean up. Everybody do their share. This is minus 4x. Uh-oh, then this is minus 4. Okay, over a common x minus 4x plus 4. And apparently we went to green, x plus 4. All right, I know the numerator is going to factor, but I don't think anything results in canceling. So I'm going to go through that process because we should take out a negative. And then just visualize that when I take out a negative, it's going to be x squared minus 4 or plus 4x plus 4. What multiplies the 4? And the same two numbers add to 4. 2 and 2. So when I take out a negative, everything becomes positive, and then this happens. Unfortunately, it doesn't result in canceling. Sometimes it does. This is why I went through this. This would be the reducing at the end. Reduce fractions. That's like if I did what the other teachers did. Step 1, get a common denominator. Step 2, make sure every fraction has a common denominator. Step 3, add the numerators, put them over a common denominator. 4, simplify. That includes any factors that are common. I don't know. So, that's the wording of the map and how to do this. Okay, so do be very aware. So in the denominator, leave the denominator or factored out because it may end up being a cancel factor with the numerator when you do that. But it didn't. So I don't have that happening. Okay, I'm ending the movie so it can be done. But here's what we're doing. I'm going to have them do this in class, that one, and these two, just because it's fun. And that was my original plan. So we're just going to improvise. Okay, here we go. Ending the movie. You guys can look at the keys online for those that are missing. How do I get out of this? Oh, Samula struggles.